Imagine a storm, not on Earth, but millions of miles away, right from the heart of our Sun, that can affect our lives on Earth. This is the thrilling world of solar storms, also known as space weather events. These powerful disturbances are born from the Sun's intense magnetic activity, releasing an energetic dance of charged particles and electromagnetic radiation into the vastness of space. But don't be fooled, while these solar storms can captivate us with spectacular displays of auroras, they are not just celestial fireworks. They carry a force that can impact our planet and the technological systems we so heavily rely on. Originating from the fiery surface of our Sun and journeying across the solar system, these storms are a testament to the dynamic and intriguing nature of our universe. Now, let us delve deeper into the heart of these solar storms and understand how they work. Solar storms are not random occurrences, but the result of a fascinating dance of energies and particles. To understand this celestial ballet, we must venture into the heart of our solar system, the Sun. The Sun, with its fiery temperament, is the cradle of solar storms. The Sun's magnetic field is the maestro, directing this cosmic performance. This magnetic field is not static. Instead, it undergoes dynamic changes over an 11-year period known as the solar cycle. Much like a symphony, the solar cycle has its crescendos and diminuendos. During periods of high solar activity or solar maximum, sunspots appear on the Sun's surface. These sunspots are not mere solar freckles, they are regions of intense magnetic fields that serve as the birthplaces of solar flares and coronal mass ejections, the main characters in our solar storm story. Solar flares are dramatic bursts of energy, releasing X-rays and ultraviolet radiation with the brilliance of 1,000,000 hydrogen bombs. Coronal mass ejections, or CMEs, are the Sun's grand gestures. They expel massive amounts of charged particles into space, creating a solar wind that carries the Sun's influence far beyond its visible surface. As these solar particles journey through space, they follow the lines of the Sun's magnetic field, like dancers following their choreography. When these particles encounter the Earth's magnetic field, a new act in the solar storm ballet begins, leading to stunning auroras or potentially disruptive geomagnetic storms. In this cosmic ballet, every step, every spin, every leap is driven by the intricate interplay of magnetic fields and charged particles. Understanding this dance is key to unraveling the mysteries of solar storms, predicting their occurrence, and preparing for their impact. These cosmic phenomena, while fascinating, can have significant effects on our planet. But as we'll see in the next act, with understanding comes the power to protect and persevere. Join us as we explore the impact of solar storms on Earth. When the fiery rage of the Sun reaches our planet, its effects are both breathtaking and alarming. As solar storms barrel towards Earth, they bring along a spectacle of cosmic proportions, the awe-inspiring auroras. These vibrant light shows paint the night sky near the polar regions as the solar particles interact with Earth's magnetic field. It's a dazzling display of nature's power, one that leaves spectators spellbound. But these celestial fireworks are just one side of the story. Beneath this visual splendor lies a more disruptive aspect of solar storms. The same charged particles that light up the night sky can wreak havoc on our modern technology. Think of it as a cosmic static shock, but on a much larger scale. Satellite communications, the invisible threads connecting the world, can be disrupted, leading to interruptions in television broadcasts, internet services, and GPS navigation. This can pose a significant challenge for sectors like aviation and maritime industries that heavily rely on accurate navigational data. Power grids, too, are not safe from these solar outbursts. The surge of charged particles can induce currents in power lines, causing voltage fluctuations and, in severe cases, wide-scale blackouts. Remember the Quebec blackout of 1989? That was the handiwork of a solar storm. Moreover, spacecraft in orbit are exposed to increased radiation levels during solar storms. This can affect their electronic components and overall functionality, posing risks to both satellite operations and the safety of astronauts. So while auroras might be the face of solar storms, the more disruptive effects are often hidden from sight, silently impacting our technologically driven lives. As we continue to extend our reach into space and deepen our reliance on technology, understanding and preparing for these solar storms becomes more critical than ever. With such serious potential threats, how can we protect ourselves from these solar tempests? Stay tuned as we delve into the measures we've taken and the future of our battle against these celestial disturbances. Our best defense against solar storms is to understand them better and prepare accordingly. To mitigate the risks from solar storms, it's vital to keep a vigilant eye on our fiery celestial neighbor. Space agencies and observatories worldwide are on this mission, continuously monitoring the sun's activity. They track the formation of sunspots, the emergence of solar flares, and the expulsion of coronal mass ejections. They're like our cosmic weather stations, providing early warnings of impending storms. This information is invaluable. It gives satellite operators, power grid managers, and others a heads up. It's a bit like knowing a hurricane is heading your way. You have time to prepare, to shield your systems, or even to temporarily shut them down if necessary. But it's not just about reacting to the warnings. Proactive measures are also essential. For instance, engineers design satellites to be robust, to withstand the onslaught of charged particles during a solar storm. They're equipped with radiation-hardened components and shielding materials. These satellites can weather the storm, so to speak, ensuring essential communications and services remain uninterrupted even during space weather events. Power grid operators also have protocols in place. They can adjust the electricity flow and distribution in response to solar storm warnings to prevent overloading and blackouts. Aviation and maritime industries, too, are not left out. They have backup communication channels ready to take over during high-frequency radio communication blackouts. It's a collective effort, a global endeavor to safeguard our technology-dependent society from the potential hazards of solar storms. But as with any scientific endeavor, there's always more to learn, more to understand. As our technological footprint expands, so does our vulnerability to solar storms. That's why the work of space weather scientists, engineers, and operators is so crucial. They're not just monitoring the sun, they're helping us navigate our future in an increasingly connected yet potentially disrupted world. As we continue to rely more on technology, our need to understand and prepare for solar storms becomes even more crucial. As we step further into the future, our fight against the effects of solar storms continues. Undeniably, our society's reliance on technology is growing at an exponential rate. This makes us more vulnerable to the disruptive effects of these cosmic tempests. Understanding the complexities of solar storms, therefore, becomes more than just an academic pursuit. It's a matter of global security and economic stability. Ongoing research is aimed at demystifying the behavior of our sun. Scientists across the globe are working tirelessly to improve space weather forecasting models. These models are integral in predicting the intensity and potential impact of solar storms. The goal is to provide timely and accurate warnings, giving us a window to prepare and respond effectively. Imagine it as a cosmic weather forecast, alerting us to when we need to batten down the hatches in anticipation of a solar storm. But the battle isn't just being fought in research labs and observatories. It's also happening in the corridors of power, where decisions about infrastructure investment are made. Governments and industries worldwide are recognizing the need to build resilience against space weather events. This means investing in infrastructure that can withstand the effects of solar storms. For instance, power grids can be designed with safeguards to prevent widespread blackouts during severe solar activity. Satellite systems can be equipped with protective measures to ensure continuity of services during space weather events. The challenge is immense, but so too is the human spirit of innovation and adaptability. We've weathered many storms throughout history, and solar storms will be no different. With the right combination of research, preparedness, and investment, we can turn this celestial challenge into an opportunity to build a more resilient, more secure future.